All right, I want to make sure I don't leave anything out. So I'm going to kind of extend the last example, 625, by discussing multiplicity, and we'll do example 626, which is actually where we talk about multiplicity. Sometimes there are multiple factors of a polynomial that, that refer to the same zero. It's kind of a strange concept to understand graphically. Although I think that if you were to do your own investigations in what this looks like graphically, you would be kind of, I don't know, kind of impressed or kind of intrigued by how this works. But basically what multiplicity refers to is when you have more than one factor or more than one of the same linear factors. So here we have this crazy x to the fifth power polynomial. There's x to the third in here. There's an x squared in here, so that's going to combine to make an x to the fifth. I'm not going to expand this out just because it's not the best use of my time right now. But if you want help on that, I'm sure to help you out. Just ask. So what this tells us is that x plus 3 is a factor 3 times. So it's like having x plus 3 times x plus 3 times x plus 3. And here x minus 2 is squared, so it's like having x minus 2 and x minus 2. So that means that my zeros for this polynomial function are at x equals negative 3, but it happens multiple times. If it happens multiple times, then we're going to abbreviate that. We'll say x is equal to negative 3 with a multiplicity of how many times? 3 times. All right, 3 times. And over here, x is also equal to positive 2 with a multiplicity of 2. All right, so, and maybe the 3 and the 2, maybe that was a bad example because now you're like, well, there's a 2, so there's a 2. Is that what we're saying? If I made this a 4, let's say I said it was x x minus 2 to the 4th power, then we would have x equals positive 2 with a multiplicity of 4. If I said that this was x plus 3 with no exponent there, we would just say that x is equal to negative 3, and we wouldn't list that it's a multiplicity of 1, because that's not multiplicity, that's just a singular root. But if we had any other number here, let's go ahead and say that there are 2 of those, then we would say how many times does x equal negative 3? And x equals negative 3 in this case twice. Because if we were to rewrite out this function in listing all the factors separately, all right, not expanded fully, but with all of the various factors, it's going to look like that, all right? Which, this kind of looks long and drawn out and complicated and whatever, but you have the skills to multiply, you have the skills to multiply, you have the skills to multiply. And we've multiplied binomials by trinomials before, so you could do it that way too, however way whichever way works for you. Now, to extend out example 625, and this is kind of what I'm getting at with writing this out in this way right here. If I look back at that last example where x was equal to 2, 1, and negative 3, but instead I added a multiplicity of 2 on that negative 3, all that means, folks, is that x minus 2, x minus 1, and then x minus negative 3 is listed as a factor twice. So we would have all these things that we would multiply out. And it's not too terribly difficult to do that. It's a little bit laborious, which is okay. Here, if I multiply these out, I get x squared minus 3x plus 2. If I multiply these out, I get x squared plus 6x plus 9. Now I'd have to multiply a trinomial by a trinomial. That can be pretty cumbersome, but you do have the skills to do that. And so what I want you to see here is that when we're talking about multiplicity, we're just referring to having the same zero multiple times. All right, so enjoy that.